Big Bud 747. Big Bud 747 does not look like a tractor. It looks like a factory that somehow grew wheels. Built in 1977, this giant machine was made for one reason: to pull massive equipment across massive land. Normal tractors could not cover enough ground fast enough on huge farms, especially when farmers needed deep tillage. So Big Bud went extreme. It used around 2100 horsepower, huge tires, and a body so wide that it could dominate a field just by standing there. The weird part is not just the size, it is the purpose. This machine was not built for show at first. It was built because some farms became so large that ordinary equipment started feeling small. Big Bud could pull deep rippers across hard soil and cover huge areas with fewer passes. But its strength was also its problem. A machine this big is hard to transport, hard to service, and only useful on certain farms. Still, it became a symbol of one idea. When land gets bigger, machines get ridiculous. ROPA mouse. The ROPA mouse looks like a giant mechanical animal feeding on a pile of crops, but it is not destroying anything. It is cleaning and loading sugar beets. After harvest, sugar beets are often dumped into huge piles near the field. The problem is simple. Those piles are dirty, heavy, and difficult to move quickly. That is where this strange machine comes in. The mouse crawls along the pile, pulls beets into its wide intake, removes loose soil, stones, and plant material, then sends the cleaned beets up a long conveyor into trucks. It looks weird because it does several jobs at once. It feeds, cleans, sorts, and loads. It also has moving arms, conveyors, and a cabin that makes the machine feel more like a creature than a vehicle. But the logic is smart. Every bit of dirt removed in the field means less useless weight on the truck, so this strange beet-eating monster saves time, fuel, and transport cost. Grape harvester. A grape harvester looks brutal at first. It drives over the row, surrounds the vine, and starts shaking it. From the outside, it almost looks like the machine is attacking the vineyard, but it is actually doing a very controlled job. Grapes are delicate, small, and expensive to pick by hand. On large vineyards, hand picking can take a huge amount of labor and time. So engineers built machines that straddle the vine row and use flexible rods or shaking systems to vibrate the plant. The ripe grapes break loose and fall onto catching plates inside the machine. Then conveyors move them into storage bins. The weird part is the method. Most harvesters cut, lift, or pull crops from the ground. This one uses vibration. It does not want the whole plant. It only wants the fruit. And when it works correctly, the vine survives. The grapes are collected fast, and the farmer finishes a job that once needed many workers. Tree spade. A tree spade looks like a giant metal claw built to steal trees from the earth. But its job is not destruction. Its job is transplanting. Moving a mature tree by hand is almost impossible because the roots spread deep and wide. If you cut too much, the tree dies. If you leave too much soil, the tree becomes too heavy to move. So the tree spade solves both problems at once. It uses several long metal blades arranged around the trunk. Those blades push into the ground from different sides, forming a cone-shaped root ball. Then the machine lifts the entire tree with its soil still wrapped around the roots. That is the weird genius of it. It does not just move the tree, it moves the tree's little world with it. Landscapers use these machines for parks, farms, nurseries, and large properties. It looks dramatic, but it protects the plant better than a rough manual dig. Mechanical tomato harvester. The mechanical tomato harvester is weird because it did not just change farming, it helped change the tomato itself. Early tomato harvesters had a serious problem. Tomatoes were too soft. If a machine shook, pulled, or dropped them too hard, they turned into pulp before reaching the truck. So engineers and plant breeders had to work together. The machine needed to harvest faster, but the crop also needed to survive the machine. That led to tougher processing tomatoes with firmer skins and a more durable shape. These tomatoes were not designed mainly for fresh eating. They were built for sauces, paste, and canned products. The machine would cut the plant, shake loose the tomatoes, separate waste material, and load the crop in bulk. The weird part is the relationship between biology and machinery. Instead of only asking, how do we make a gentler machine? Farmers also asked, how do we grow a tomato that can handle the machine? That changed modern tomato farming. Bale barron. The bale barron looks like a farm machine that learned warehouse packing. Small square hay bales are useful because they are easier to feed, sell, and handle in smaller amounts. But there is one big problem. They create a lot of manual work. Somebody has to pick them up, stack them, move them, and store them. That takes time, labor, and back pain. The bale barron solves this by collecting small square bales and bundling them into clean packs. Instead of dozens of loose bales scattered across a field, the farmer gets tight, organized bundles that can be moved with a loader or forklift. The weird part is how industrial it feels. Hay is messy, dusty, and old-fashioned, but this machine turns it into something that looks like a shipping unit. It brings packaging logic into the field. That means faster loading, cleaner storage, easier transport, and less hand labor. It is not weird because it is huge. It is weird because it makes hay look organized. John Deere CP770 Cotton Picker. The John Deere CP770 cotton picker is strange because it does not just harvest cotton, it builds massive wrapped cotton modules while moving through the field. Older cotton harvesting needed more steps. Pick the cotton, dump it, move it, build modules, protect them, transport them. Every step needed time, machines, and workers. This machine combines several of those jobs. It picks cotton from the plants, cleans part of the trash out, sends the cotton into an onboard chamber, compresses it, shapes it into a huge round module, wraps it, and drops it in the field. The result looks bizarre. After harvest, the field can be filled with giant white or yellow wrapped cotton rolls sitting like oversized marshmallows. But the system is powerful because cotton is bulky. Loose cotton takes up space fast. Compressing and wrapping it immediately protects the crop and reduces handling. The weirdest part is watching a harvester produce its own finished package. It is part picker, part factory, part rolling storage system. Carbon Robotics LaserWeeder. The LaserWeeder sounds like something from science fiction, but the problem is very old. Weeds steal water, nutrients, sunlight, and space from crops. Farmers have always fought them with hand labor, tillage, herbicides, or mechanical tools. Each method has a cost. Hand weeding is slow. Tillage can disturb soil. Chemicals can be expensive and controversial. So this machine takes a strange approach. It uses cameras, artificial intelligence, and laser energy to kill weeds. The system scans the crop row, identifies what is a crop and what is a weed, then targets the weed with heat. It does not need to pull the weed out. It damages it enough to stop growth. That is what makes it so weird. A farm machine is using computer vision and lasers in a place where people once used hoes. It feels like a weapon, but its target is tiny, unwanted plants. The logic is simple. Fewer chemicals, less hand labor, and more precise weed control. Nio-OZ Robot. The Nio-OZ Robot looks almost too small to be taken seriously. That is what makes it interesting. Most people imagine farm machines as giant tractors, harvesters, and sprayers. But many farms do not need bigger machines. They need smaller, smarter ones. Market gardens, vegetable farms, and specialty crop fields often have narrow rows and delicate plants. A huge tractor can be too heavy, too wide, and too expensive for that kind of work. OZ is designed for jobs like weeding, carrying tools, soil preparation, and helping with repetitive field tasks. The weird part is the scale. It looks more like a robotic cart than a traditional tractor. But that is the point. Small machines can work in spaces big machines cannot. They can reduce walking, reduce repetitive labor, and help farmers manage crops with more precision. It shows a different future of farming. Not every machine has to be a monster. Some of the strangest ones are small, quiet, and useful. Steep slope grape harvester. Some vineyards are planted on land that looks almost impossible to farm with machines. The slopes are steep. The rows are narrow. The ground can be uneven, and one wrong movement can become dangerous. For a long time, this kind of harvesting depended heavily on hand labor because normal tractors and harvesters were not safe or practical there. That is why steep slope grape harvesters are so strange. They are built for places where ordinary machines would struggle. Instead of looking wide and heavy, they often need to be compact, balanced, and controlled. Some are designed for terraces and steep gradients, allowing mechanical harvesting in vineyards that once seemed too risky for large equipment. The weird part is not just the machine, it is the environment. A harvester on a flat field makes sense. A harvester working on a steep hillside feels wrong until you understand the need. Farmers want speed, safety, and lower labor dependence, even in difficult terrain, so the machine adapts to the land.